Okay, so today we're going to go over the Similarity Quiz 1 from Friday, October 16th. In general, the class didn't do super great on this, and I take that to mean that I did not cover the material sufficiently. I don't blame this on any of you. Clearly, I made a misjudgment in what you were all ready for, so that's on me. We're going to go over this entire quiz step by step, and we're going to spend this week continuing to work on similarity. So, without further ado, here's one question right here. For this one, it said that figure A prime, B prime, C prime, and D prime below is a dilation of figure ABCD. So we can see ABCD is the larger shape, the prime shape is the smaller one, so the scale factor has to be less than 1. We know that right off the bat. A scale factor, if we go from a bigger shape to a smaller shape, we are dealing with a scale factor less than 1. So right out the gate, those two should be impossible. It is confirmed that this is a dilation. We don't have to guess if this is a dilation or not. But we do have some side lengths to go off of. So I'm just going to choose the smaller number because those are typically easier to work with. Somehow we went from 15 inches to 5 inches. Now, to dumb down what a scale factor is, like all the way to its base principles, is you're figuring out what do I multiply the original number by to get the new number. That is a gross oversimplification of what it really is, but if you are struggling with this unit, you can get by with that knowledge. So a scale factor is what do I multiply the original number by to get the new number. In this case, 15 times something gave me 5. Is it 15 times 3/5 or 15 times 1/3? You can use a calculator to help you on this. Calculators like this one do well with fractions. If not, I've told all of you guys where to go to get one. Desmos.com/scientific. Great calculator, and it does fractions. But if you try to figure out, okay, well, 15 times something equals 5, divide both sides by 15. Even without a calculator, you can do this. X equals 5/15 simplifies to 1/3. So that's what the answer should have been for this problem. We're going to move on to the next one after I clear that. Good. All right, next question. Which of these 4 triangles are not similar? Or excuse me, which of these are similar? Excuse me, I just misread it. All right, it looks like only 2 of these have equivalent angles. That's a good start. Nothing else, I mean, those clearly can't be it. So 1 and 3. So this one right here. Nothing else is really going to work. 2 and 3, no. 1 is not a right angle. 2 and 4, maybe, except the angles should not have changed, and they did. 1 and 2, again, different angles, definitely doesn't work. If nothing else, if 2 shapes are similar, they have to have the same angles. That's non-negotiable. This one, drawing of a butterfly is shown below. What changes were made to the upper portion to form the lower portion? Okay, so my original shape is everything above that red line. That's where my original shape is. In fact, I think I have a line tool that I can actually use. So everything above that red line is my original shape. How did I get the original shape up top and turn it into the bottom shape? Well, for one, it's a different size, so we know dilation has to be part of it. So right off the bat, it can't be this one and it can't be this one. Dilation has to be a part of it. Also, we have to decide, are these shapes facing the same direction or are they facing a new direction? We can kind of see, like this one, it's almost like a heart that's kind of tilted, but we look down here and the hearts are not facing the same direction. Think back to your transformations. A translation is going to look like the same shape, but it's just sliding. That shape will still be facing the same direction. A reflection, however, if you can kind of picture this shape acting like a mirror for that red line, that it's being shrunk and then reflected across that red line, you can see where that would come from. This is a dilation and reflection for this problem. We're going to move on to the next number, which is, I guess, number 4. I should point out I'm doing this on student preview mode, so these questions might be in a different order than you got them. So I do apologize for that, but this way I can go over each problem individually. Number 4, this is a dilation and rotation. It tells you that. It's a dilation and a rotation, and it resulted in B prime. And that wants to know which of these statements below must be true. It's either that they are not similar or congruent. It is that they are similar and congruent. They're congruent but not similar. And they're similar but not congruent. First of all, one of those answer choices is utter nonsense. It's congruent but not similar. Congruent means it's exactly the same. That would be like me saying, oh, these two pens are exactly the same, but they're not similar. That's dumb. That doesn't make sense. That's not a real thing. So that's idiotic. That's impossible. The rest of these could work, so let's double check. First, I'm going to verify if this really is a good scale. So like the short side was 3 units wide. The new short side is 1, 2, 3, 4.5. So we went from 3 to 4.5. Okay. The long side went from 1, 2, 3. The long side went from 4 and is now 1, 2, 3, 4, 5, 6. So we went from 4 to 6. What do I multiply 4 by to get 6? So let's see. 4 times something equals 6. Divide both sides by 4. And that leaves me with x equals 6 over 4. That simplifies to 3 over 2. So theoretically, I should be multiplying everything on the left side times 3 over 2. So, like, obviously this one works. Like, 4 times 3 over 2 does give me 6. Is that true with this? If I take 3 times 3 over 2, does that give me 4.5? Well, I'll start by going ahead and multiplying. That gives me 9 over 2. 2 goes into 9 4 times with 1 remaining. So yes, so far that checks out. So they did shrink to the same amount. We can clearly see they're not the same size, so they are definitely not congruent. We know that. So not congruent, that works. This one says they are congruent, so we know it's not this. So it's either they're not similar or congruent, or they are similar but not congruent. Those are the 2 remaining answer choices. And if you kind of look, you can see, well, the scale factor did work for all the sides, so it did shrink according to one common scale factor. That means they are similar. Not congruent because they're different sizes, but they're similar. They shrunk to the same amount for all sides. It just looks like they also rotated, which the question did tell us it rotated first. Let's go ahead and check the next one. This one a bunch of people had questions on during the test. This one says triangle similar to JMN it will be drawn on the coordinate plane using points J and K, meaning it already gave you these 2 points. This is used and this is used. So we draw that line going down because we know that's going to be a part of it. And then it says what could be the coordinates of a third point of the triangle. And we're looking for something similar to this triangle, which is 1, 2, 3, 4, 1, 2, 3. So this is a 4 by 4 right triangle. The base and height are both 4. Now we can look and see what the height of this shape is, because assuming this is going to be similar, we need to keep both the height and base the same. Otherwise it's not going to follow the same dimensions as this one. So the height of this new triangle is supposed to be 1, 2, 3, 4, 5, 6, 7, 8. Oh, easy. So all they did was they took this 4 and turned it into 8. That's a scale factor of 2. They multiplied everything by 2. All we have to do is select which of these 4 coordinates will give us a base for this new triangle that will also be 8 units wide. So the first option is at -1, -3. No, that's laughably different. That doesn't work. So that can't be it. -1, -11. -1, -11. That's not even on the graph. There's no way that that could possibly be the answer. The next point is -5, -7. So -5, -7 would be about here. That looks about right. Let's count the distance here. 1, 2, 3, 4, 5, 6, 7. Yeah, 8. So we have 8 for the height, 8 for the base. That matches the dimensions if we were to scale it up by 2. So I'm not even going to waste my time with the third answer choice because, frankly, there is no -15 on this graph. Here's a hint. If it's not on the graph, there's no way it's the answer choice. Let's go ahead and wipe the slate clean and move on to the second to last problem before I get to what I guess most people consider to be the hardest one. Which quadrilateral is not similar to the original PQRS? So we can look and see the original was 2 high by 3 wide. We just gotta find something that either shrunk or grew to the same amount. And you can kind of already look and see which one the answer is. The answer is going to be 3. And you can kind of see that because it's a little bit less short and wide. The other ones are very clearly short and wide. This one, a little bit less so. The reason being, if I went from this shape to 4, all I would have to do is divide both the height and the width by 2. Because suddenly I went from having a height of 2 to 1. I went from having a width of 3 to 1.5, so that checks out. If I go from that shape to, say, 1, for this one, I went from a height of 2 to a height of 3. So I'd be multiplying that. Let's see, I went from 2 to 3. So 2 times what gave me 3? Oh, so that would be 3/2 would be my answer. And if I do the same thing for the base, I do 3 times 3 over 2. That's going to give me, we already know, 4.5. And yes, that is the new base, so that checks out. So 1 is good, 4 is good. You look at 3, though, and 3 also has a height of 3, which means the scale factor should be 2/3. And 2/3 times the original base, which was 3, should be 4.5. But then we look and we see, oh, it's only 4. They rounded down, but that's not okay. If you're looking for something exactly similar, you can't round. You can't estimate. You can't guess. So this one, the answer is going to be 3. So that's it for number 7. The very last problem. This is the one that more people ask me about than any other problem, and I kind of see why. The question wasn't super clear in what it was asking. The question was saying a piece of artwork has similar rectangles that are translated. Which one best represents this artwork? So let's see. So I'll rephrase this. One of these answer choices has similar rectangles that are translated. Which one best represents this? Forget about artwork. Forget about the word artwork. This is showing you, hey, there are 2 rectangles. They should be similar. Which one is it? The end. Close the book. End of story. All right? So we have an original shape that was, it looks like 5 by 15, and that's true for all 4 answer choices. All 4 of them started as 5 by 15. And now we just look and we're like, okay, so the short side was 5. Now the short side is 1. What would have to happen to make that true? It would be, okay, so 5 times what equals 1? Well, that would be 1/5, wouldn't it? So I would have to do 1/5 times 15 and see if that matches the new long side, which is 5. Well, you can kind of look at it and be like, no, 15 times 1/5 would equal 3, not 5. So we already know this answer choice is gone. That's done. Let me switch colors for my marker here. The next one, we have the long side was 15, now it's 3. The short side was 5, now it's 1. Let's see if this works out. So the long side went from 15 to 3, so 15 times something gave me 3. What would that something be? Divide both sides by 15, leaves you with 3 over 15, which simplifies to, that would be 1/5, wouldn't it? So I know 15 times 1/5 equals 3. We know that. But what about 5 times 1/5? Does that equal 1? Yeah, it does. That does work. That means that that was my answer choice all along. So do watch out for that. And the other ones I'm not even going to go over because we found our answer. There's no use wasting our time with this. We'll continue to practice similarity this week because, I mean, as I've said numerous times, you know my hands are kind of tied with how and what I'm supposed to teach you guys. I'm still going to try to weasel in some of my own material because, well, hopefully some of you will agree that I was able to explain a lot better this way than I was with everything we did last week. But that is it for the review today. Hope this helped, and now go do the retest. Okay? Good luck.